Let's have a look at sketching graphs. Because as I said yesterday, if you can get the picture, finding domain, range, all those sorts of things becomes a heck of a lot easier. So once you've collected data, and that data might simply be the equation of it, but you plot them, and then you can see any patterns that might exist between the data. The type of pattern is determined by the shape of the data. If you can approximate it by a known function, then obviously the analysis of that data is easier and predictions then become possible. I guess that's what you do in science. You might end up with a log curve or something like that, so you know it's exponential or that sort of thing. Consistent scale though is very important, otherwise you get very strange shapes and you make incorrect predictions and things like that. Known functions. If we know what a function looks like just by looking at the equation, life becomes very easy. The y-intercept, of course, is very easy to find. You substitute in x equals 0. X-intercept, similar, not always as easy to find though, depending on the equation you end up with, but you make y equals 0. Once you've got those intercepts, combine that with the shape of the curve, and you can pretty much get a good estimate of your graph. There are specific features for each type of function that you look for. And never forget, I guess, the basic Year 7 idea. If in doubt, plot points. Draw up a table of values and investigate what's happening if you're unsure. Let's start with the most basic function of them all, the linear function. And the most basic of the basic function would be that one there, y equals x. Now, if you get a straight line, then you know the data has direct variation. As x increases, y increases. So it's a direct variation. As I say, that's what we call the linear function for obvious reasons. It's a line. In science, you've probably done this when you are plotting data. Even though experimental data might not lie exactly on a straight line, you'd be incredibly lucky if it does with most experiments. A line of best fit then is drawn in. As long as you can see the points and you go, yeah, that looks like a linear relationship, so let's try and draw a line of best fit between the data. Every straight line can be transformed from the basic equation, y equals x. It might be a rotation, it might be a reflection, it might be a translation, or as I say there, it could be a combination of all of them. So how do you recognize? If for some reason you looked at the equation and you went, I just don't know what this is, how would you recognize the linear function? We've seen this before, y equals mx plus b. So what are we looking for here? Y is to the power of 1 and x is to the power of 1 as well. That's probably a pretty big hint that we've got a linear function there. When you express it like this, with y being the subject, you can look at that equation and tell good pieces of information. The coefficient of x is always the slope of the curve, or the line. And b, the constant, is always the y-intercept. There are some special ones, of course. Lines that are parallel to the x-axis would have the equation y equals some constant. So that one there, it goes through the point 32, must have the equation y equals 2. It still satisfies y equals mx plus b if you think about it, because the slope of that line is 0. So you've got 0x plus the y-intercept, and the y-intercept would be 2. So it still satisfies that. Vertical lines, a bit harder to see how the y equals mx plus b comes into it, but you can get it from this. So x equals k. So x equals some constant. In this case, it would be x equals 3. How on earth do we get y equals mx plus b from that? I mean, the slope is infinite. Well, sometimes we think of infinite as 1 over 0. Well, if we think of it like that, then you're going to go y equals 1 over 0x. Multiplied by the denominator, the y disappears, you now get x equals. How we get the y-intercept to do that, I'm not quite sure, but there is some sort of a relationship there. So they're very special ones, of course. Basic sort of question. You got to show that question. All you really need to do is substitute in and show that it works. So show that 2, 4 lies on the line. Well, what do you know? 2 plus 4 is indeed 6. So yes, it does work. So we have shown that it lies on the line. That's the first bit of theory for today.